Hey guys, hopefully that starting infographic worked. It made it so it's not like super awkward when I start the stream. There's like a delay with YouTube, and I'm like sitting there trying to make sure it started. I also changed around some stuff with my audio and video. Let me know if you can't see or it looks anything off. But otherwise, I guess I'll wait a few minutes for some other people to join. I don't exactly know. Um, Really, I didn't plan a ton of where all the next steps of this layout are going to be. I'm assuming just working on the power pour some more, but I'm not completely positive. Let me know if anyone has any thoughts on that. Um, but I guess one thing I can do is at least make these somewhat consistent. Ideally, I should probably make the footprint. Oops. I should make the footprint have all of the vias built in. Looks and sounds fine. Fantastic. How's it going, everyone? Oh, I had a double hit via there. Oh, I had a couple double vias. That's one thing I believe that they fixed in this version, to where the DRC catches those, but I don't know. How's it going, Audrey? All right, so yeah, I'm just gonna space out these vias. Again, like I said I think I've mentioned it a couple times, this is like the only um, footprint that I've really seen that has not a single ground pin on here. It just has a center pad, which they obviously ran out of room on the IC to have the pins, but signal integrity wise, it's probably not good. Man, I cannot make these symmetric. Okay. All right. Okay, so like I said, most likely on the actual final version here, I'll have thermal vias also in the pad, but for the time being, it really doesn't matter that much because it's just going to flood and fill these. So the only reason you would really need them to be where the mask is. Oh, and I need to fix that. One pain with PCB libraries is sometimes it won't fill the solder mask, so it just leaves these outlines. But once that is fixed, most likely we'll have some thermal vias in between the spacing, and then you don't have an issue with any of the solder wicking down. But that usually is best left to be in the actual footprint, but it obviously doesn't really matter because it's done the same way. But I guess I'll just throw these on now that I've made it this far. Right click to make a via right. Yeah, that's, I need to get better at making things more symmetrical. That's obviously going to be a better way to do it. Okay, so where we left off last time, all of this is sorted. All of the rough routing for the um, mux, demux is roughly routed. And I threw on just some rough power pours here. And really the only, I I guess, tough part left is going to be how the actual power setup is done. And I completely forgot what I need to write this stuff down. I forget what we had figured out at the end of last stream. It was something along the lines of putting I think the 3v3 side down here and just bumping it to this power pour because, let me check. Oh, come on. How do I select all of these again? There you go. Oh, 3v3 goes up there. So it'd be only the 1.15 volts then that we could tie down here. Yeah, because nothing else uses the 1.15, so that's what it was. If we throw the 1.15 down on this area or to the right, and then just run the whatever it's coming from, the 1.15 comes straight from the 12 volt rail. So if we tie in and have the 1.15 regulator down here and then just run the 12 volt down, then we can keep that closer to the source. But what I am thinking might make the most sense is I'm going to redo these power pours and make them like better. And then do all of the decoupling and everything for this. So basically have the USB hub block essentially completely done. And then it does make more sense to have this rotated on a 45 because that will make both of these runs a little bit shorter. And with everything already routed on a horizontal grid, that'll make it easier when we go to rotate them. So I'm thinking we do all of this and have all of those sorted and then finish up where the actual power should be. And that will be definitely the bulk of this. And then obviously what's left is going through and making sure that, or fixing all of the differential pairs and going over what the width and spacing are for controlled impedance, if this board ends up being actually controlled impedance. USB's pretty forgiving. It probably won't have to. So, how did I have that before? I had 3v3 and 1.15. 1.15 was on that signal 2 layer. 3v3 was on the power copper layer. Oh, that's what it was. The 3v3, since it ties there, if we use that on the power side, we can just join these two together. I think that's what it was. Because we can tie... Either way, let's ignore where all that's going to run for now. And let us just expand out this pour. And we can start doing all like the decoupling caps and all that. So we're going to have to adjust where these traces are because that's going to interfere with our 1.15 volt pour. And something to be aware of when you're partitioning off power like this, even if you have the power joining, let me make my grid bigger. So even if we have like a smaller trace, obviously not like that small, but if we have a smaller trace connecting wherever the power comes in at to a pour, it's still in our best interest to make this as a pour and make it as big as we can, because all of that decoupling capacitance from the capacitors you place and the interplanar capacitance between this pour and the ground plane, they're going to be a lot stronger if you have a larger pour. So it's always in your best interest, if you can, obviously, to kind of make these as beefy as possible, even if you just have a smaller trace. Since none of these on here are going to be high powered, we really don't care about how big the leading trace up to it are, and that's really the only time you would care. And I still 45 these. It obviously doesn't matter, but looks a little bit better. All right. So I guess we can make this down a little bit. All right. So that is roughly our pour that will be the 3v3, and that'll connect to our 3v3 up there. And now what we'll do for the 1.15 is we'll just put it on the exact same location, but obviously these traces are on that layer, so we need to adjust these and move these out, and just have them join at another point. Which, why are there double hits on all these vias? I don't understand that. Unlike half of the vias I've deleted today, they've been doubles. Which is something in the past Kike had been pretty bad about, but I thought that it had been fixed in this. Guess not. In here, it really doesn't matter where the vias are. You just kind of want to make them obviously as small as possible. This length, which means, let me move this over. Actually, I'm going to extend this because if you cross over on a 45, it makes the path a little bit longer. So it's usually in your best interest to try to cross at a 45 if you can, obviously. God, this differential router is not as good in the nightly builds. Like, noticeably worse. Which doesn't make much sense to me. Because I didn't think, at least in any of the change logs, that they really messed with it that much, but apparently they did. Alright, so now these are going to be a little bit more painful. Let me see, how much of the 1.15 is even here? Okay, I guess if we just straighten this out, then we can move everything else there, so that won't be that big of a deal. Yeah, there's double hits on like half of the differential pair vias. Something, I guess, in the way that I start the next trace makes it place two vias, which is really strange. Because that's something I didn't see with the old version, even the issues that differential router has had. Because are there two there? No. All right, so that gets us out of there. Now, this one is likely going to be a little bit rougher to do. I guess we can maybe do it down here. It'll make this path a little bit longer, but maybe we can work around it. So let me see if this made two vias anywhere. Yes. So that's got to be a bug. Has anyone used the differential router in the nightlies? Because on every second via, it places two, which it depends on the fab house. Some of them will get mad at you if you have that. Others, they just ignore it. I believe in this DRC, it does show double via hits. The old one didn't. So you would have to use a third-party DRC to actually check it. That's the one cool thing with also this new nightly version is the DRC is really good, or really good compared to what it was. Okay, so with this, maybe let's have these go horizontal and then drop down. So this is, again, what I've been saying a bunch. Stuff like this is why I definitely, especially doing differential pairs, I don't even remotely try to do them like well at the start, because so often you end up having to do stuff like this and redoing them. So if you try to make them perfect at the start, you're going to spend so much time just fixing them and adjusting them. So at the end, once everything is placed and everything looks pretty good, that's when I'll actually adjust all the spacing and widths and do like the final route. And it's not just for differential pairs. That's how I pretty much route everything. You just save a lot of time in the long run. And same thing with how some of these traces are probably a little closer together than they should be. We can change that when we do the final route. Okay, so that time it didn't do two vias. I have absolutely no idea what I did differently. Obviously, I did something. Okay, so now everything for there is outside. So what we can do here is duplicate this, edit it, change the layer to signal 2, and drop that to 1.15. So the USB hub is on our top trace here. There will be 1.15 on this layer, referencing this ground, and then 3v3 will be on this layer, referencing this ground. Oh, one thing I wanted to do is check the data sheet. So something like this, since we obviously have, here, I'll show it better. So for the 1.15, they're spread evenly around the part, and then for the 3v3, they're spread evenly around the part as well. So there's no possible way to, like, what you would normally do if, say, there's like 3v3 on this side and 1.15 on this side. You would have one pour here for the one voltage rail and then the other pour here, because what you're shooting for is, and I guess let me open this up because that's bigger than over here. So if your USB hub's on the top layer, if you have your power pour, you want that to be as close to the traces and to the physical IC as possible, where here we have to have it a little bit lower. So if the datasheet or something said which voltage rail is like the higher speed or the logic side, that could probably help. I know the 1.15 is for what they call the core function. So I'm assuming that that is probably the higher speed and higher priority, which is one of the reasons I put it up on the higher layer. Ultimately, it probably doesn't matter a ton, but you never know. Okay, why Are these still referencing? Oh, do I not have ground on any other layer yet? Yes, that is why. Okay, so let me duplicate ground on all the layers as well. How's it going, Intermit Tech? Okay, so one really cool thing is they let you throw ground on all of these all at once, which is something that had been really annoying that they didn't in the past. So let's see if that works. Off, yes, so ground on the ground layer, get rid of that. Now that's our power, and then it's on ground 2, so we're all good. And one thing that I'll go over a little bit more when we're actually doing the differential pairs. Ooh, that looks really ugly. um, One thing that I'll go over when we're doing these. Okay, why did the differential pairs get completely broken over here? Um, I have absolutely no idea. That's one thing that's been, I guess, not so much a bug, but something that I know there have been multiple bug reports about how downstream stuff will just get completely like bugged, where it'll adjust the traces when you nudge it upstream like really bad and in a way that doesn't make any like logical sense. But I don't know if they're ever planning on addressing that or whatnot, because I obviously never touched anything over on this other side, and it still made all of these move, which shouldn't happen. But anyway, what I was gonna say is, so I typically, unless it's high voltage stuff, I will flood ground on every single layer other than if we have like a full power pour. So like this routing layer on signal 1, I have it flooded with ground. You'll see some people who will only have ground on the dedicated ground layers. The only time that it really makes a difference in a negative way doing it this way is with differential pairs, because you will get, so like on this differential pair, the majority of this field gets coupled between each other and the reference plane below because it's a lot closer, but some of it will get coupled to this outer strip of ground. So when you use like a differential pair calculator or try to do any controlled impedance, it'll be a little bit incorrect. So what I will typically do is wherever the differential pairs are, I just do a keep out and keep out any of that copper. It doesn't make a huge difference, especially for USB, because like I said, it's pretty forgiving. But for higher speed stuff, it's a good thing to keep in mind, especially if it's single-ended. So like doing like a SD RAM or some of like the DDR voltage reference side, that is single-ended. So that means all of the return will be on the plane below it, and it makes it a lot easier to couple with what's next to it. So that's where it really matters. Differential pairs are pretty amazing in that sense. You get the half on each side. They're a lot more immune to that, but still something to keep in mind. Okay, I said I wasn't going to talk about that much, but anyway, okay, so let's get all of our 1.15 caps first. So it should be all of these, and these they did not lump together very good. So while I'm grabbing these, another thing that you can do on a layout like this is you can do what's called, oh, missed that. You can do either local decoupling or, oh, what's the other term? It's not general decoupling, but broadband, whatever. And what local decoupling is, what the vast majority of people are familiar with. You put decoupling caps at each IC. But on a board like this, where you have a lot of layers, you have a lot of high-speed interfaces, you can just sprinkle these around over the entire board, because at higher speeds above like 500 megahertz or starts at like 250, decoupling capacitors are essentially useless because the inductance in their leads is more significant than the capacitance side. Oh, this is going to be a pain. I was hoping this wouldn't happen. Dang it. Another reason why I don't like routing the traces fully at the start. So with like a board like this, any of the high speed signaling will be referenced, and when it has to reference the power to ground, it does it through the interplanar capacitance. So like between the power and ground here, and then the power and ground here, not through the decoupling. So they become less significant as the speeds increase. So this is going to be a pain. See, this is another reason why I don't know why they don't have grounds next to each other. Because if there was a ground next to each power pin, it would double the space to put a cap. And these are 0402, so it's not like they're big. Oh, do we actually have room there? We actually have room. Let me see. This is probably going to be a really bad idea because it's going to find so many DRC issues. Oh, it does. Why doesn't it like that? Because it's within the spacing. And now there's probably going to be no way to find that. Can I save it as a... Okay, let me see if I can grab that, because then I can search for this exact capacitor, because I don't see where it's touching any of these traces, and if we can fit them in between these as is, that's going to make a really big difference. If not, that's probably going to be a pain. Okay, so what is this? This is C19. Silk screen clipped by solder mask. Is that really all it's complaining about? Silk screen, missing connection between items, missing connection, clipped by solder mask. So that's it. So how do I get rid of, how do I change the design rules on that checker here? Silk screen clipped by solder mask. Let's get rid of all of these. And now let's see if it still gets mad at me there. Perfect. Okay, so that makes it pretty nice. So I'm guessing in one of the app notes or even in the data sheet, they probably say that for whatever size these are, what, 0.12, and with an 0402, you can keep enough space here. The issue is going to be if we have to increase our spacing on these when we do our final differential pair routes, then we'll have to move these around, but we really don't have a choice. But yeah, definitely a big miss on Microchip for not having these to be to have ground pins in between each of the power pins. That's something that I know Rick Hartley, when he does his seminars, he gets really mad at some of the IC manufacturers for how they do their pinouts on some of these. It's like they don't even think about how it actually has to be laid out, which has gotten better lately, but still pretty bad. The only possible reasoning I can think of is they didn't want to use a different footprint. Can also add error from DRC. Gotcha. Yeah, I honestly have not messed with the DRC really at all, other than from what I've seen online and just checking here. It is so nice how many more things that it covers. That is something that it definitely needed to. Like, why is that a warning? That's fine. We can worry about all those later. And then decoupling caps, obviously, standard rules. You want it to be as close as possible with as large of a trace as possible. Again, I'm just doing temporary traces for now. And I do that with pretty much everything, because anytime you start to try to put like the final trace size, it makes you like less motivated to go back and change everything, which means you're going to miss stuff. So I try to just kind of make it a rule to where I do everything just with the super small trace, and it kind of forces me to go back. So how much that overlaps just by 1. But it is nice, at least they do have a lot of power pins, even if they don't include the ground. Okay. Because especially with them near the differential pairs, it gives us a better, you'll have better signal integrity when you can have the caps closer to your pairs. But honestly, all the like rules of thumb that I know of with wanting ground in between your sets of differential pairs kind of goes out the window here, because it's just the 1.15 and not the ground in between. So some of that probably doesn't hold true, at least not as much. All right, so that's our 1.15s done. And oh wait, missed one. Oh, we do have, oh, I bet this is a, yeah, that's a test pin. I was gonna say, I didn't think there were actually any power ground pins. Oh. All right. Let me make sure that that's all of them. And I just obviously have the schematic open on a second screen. Unless you have like a higher resolution monitor, like probably not a 4K, but like a 1440p, it's really hard to do this without a second monitor, because you just run out of real estate super fast. Okay, now grab all these. The good thing about doing the decoupling caps all now and working on the local power planes also is it just cleans up the layout, so then running the rest of the power won't be as like clustered with all of these other pieces of the rat's nest. X and X. Oh, that's a extra value of cap for the crystal. I was going to say that does not seem like it should be there. Okay, I think that is it. And then something that is pretty important just for making your schematic consistent is you want to make sure, so like this one wasn't a decoupling cap for the right one. You want to make sure that you only use decoupling caps for that specific IC if you're doing the local decoupling method, like I was saying, or else you're looking at the schematic when you're like troubleshooting a board and you're looking at like C7 thinking that it's here, and in reality it's not. Used it for another part. Oh, this is annoying. But that's still pretty close. And I know there were some of the 3v3 power pins which were right next to each other, so those will probably have to, yeah, like right here. Okay, I like that a lot actually. So the X is where there's a explicit non-connect. That is something that with the non-nightly version, the stable release of KiCad, you would just see a net name, and that net name then would just correspond to nothing essentially. So it was pretty hard to tell if you actually are connecting if the non-connect there is a non-connect or if it's just a random trace. So I like that. Okay. Few more here. This is the kind of the tedious stuff that's just kind of a pain in doing layouts, which ultimately is why honestly I like the schematic side a lot more than layout. Just because there's a lot more tedious stuff with layout, and it just takes longer compared to it takes longer on the repetitive side at least, and it's just a lot of going back and like making small changes. Okay, so there's the triple 3v3. Are these all power? No, that's not power, and that's not power. So this is the one we actually care about. And when I say not power, I simply just mean it's like a logic thing or a test pin to where it's not actually getting power for the IC. So we want to have the decoupling on there, or we want to have the decoupling on here. And I don't know if I mentioned in this stream, but don't ever do this. It's against IPC standards, and it makes it when you solder it have a bridge. So you want to explicitly connect these to the power separately. Obviously, it doesn't make a difference electrically, but it does make a difference when you're assembling it, because there'll just be a copper strip, and say if you're using like an outside assembly house, they will just see a short and it won't pass their testing, even though it's pretty much impossible for them to make it pass. Okay, this should be the last one. Maybe I did that. One of these shouldn't have been. So that's a power pin. That's a power pin. Power. That is not a power pin. Oh. Neither of these are. Okay. So, just to be clear, when I'm saying they're not a power pin, it's one of the port display, and it just wanted it in the data sheet to be tied to 3v3. So there's absolutely no reason, or no, you're defeating the purpose of tying them to a decoupling cap, because they're not actually drawing in any power. Okay, so then which pins do we still need? Oh, I can't click on an individual pin on the schematic on here. That's a shame. Okay, so pin 26. Got it. 43. Got it. 53. Got it. 67. Got it. 62. Got it. 99 or 79. Okay, missing one here. Hey, and while I'm working on this question for you guys, so something I've been really interested in, and is ultimately why I do this YouTube, why I started the YouTube channel, is I do like the whole teaching side and stuff, and I've thought about doing, I've mentioned it before on the Discord channel, of doing like online, like a Udemy type or a course. I have no idea what exactly the topic would be. Yeah, I have no idea. But something I was thinking about to like differentiate, because like most of the Udemy or all of the Udemy stuff or any of the other courses, it's all just like I'd record like however many hours of content, and then you watch it and hopefully you learn. Something I was thinking that could be kind of interesting, would anyone like the idea of doing it in like a live stream format, to where it's more like you're actually taking a course and like you can ask questions and stuff like that? So instead of it just being like a static recording, which obviously the recording would stay available, It's more like you're taking like an actual course with an instructor or something like that. I mean, obviously it's a lot more time on my end, but just kind of something I was thinking about the other day. Let me know if you would like that better, worse, or don't see a need, anything like that. So now obviously we have our decoupling caps, but now we actually have to tie them into our we have to tie it into power, because up until this point they do not have power. 5, and like I keep mentioning, the all these power traces will be redone in as thick of a trace as will still fit into the pad. The DRC, once you click on one, you get the description. Oh, that is fantastic. I didn't know you could do that. So you talked about traces between pins is a no-no. However, the ground plane puts the traces. Yes, Jeremy, good point. That's something that's an absolute pain. Trying to think if there's one here. Yes, so this will do exactly what you're saying, Jeremy. So like right here, if this had a ground pour, it's going to connect all these traces to, I mean, if there were thermals on the ground pour, you would have this separate trace. So what I literally will do, and this is something I learned from Gary to do. So basically, if you keep out copper fill and do a keep out area, you can essentially box this out. Oh, don't do this. Okay, I was gonna say, don't be doing that. So now basically your copper won't be filled between them, and now you can connect it to ground just however. So that is something on any of these, if I remember, I'll always try to do, just because, especially here with no thermals, which I will add, you would just get complete flooding under there. Yeah, good point. I'm glad you brought that up, because that's something I wish there was a way to change it in like a setting, but I honestly don't know how they would do it, unless it's like a toggled option to where you can say don't connect between pads, but I think that'd be a little goofy. I think it's just a workaround, and I honestly don't know how other ECAD softwares do it. Oh, that is not on the wrong layer, not on the right layer. I think it depends on the topic, of course. Yeah, totally. Oh, come on. And that's something like I said, I haven't really got. Okay, why are you doing this? You can do double layered traces. I remember that. How do you get rid of that now? Just edit the pads to have thermal relief? No, that doesn't work. With what Jeremy said. So if these had, oh, I forgot to get rid of that. If these had a thermal, it would still connect a thermal in between each of these, which goes against IPC. So you need to force it to where there can't be any traces between here. You can override, yes, that MSCNC, that's true. That's the other way. And I had done that. The reason I say doing the keep out is it's usually faster just to draw a keep out here, doing it for just pours than changing each individual pad. But yes, either or works. And now, how do I stop doing the double traces? Oh, okay, I guess it's not doing it anymore. Another option is to set whole zone is not connected to pads. Yes, but then it won't connect to like your decoupling caps and stuff like that. But yeah, you definitely. Okay, come on. Why is it doing this? Someone's got to know this one. Why is it drawing a trace on both layers? I know that's an option here, but how do I stop it from? Okay, it didn't do it that time. Oh, that's how I'm doing the double via hits. To escape from the routing option, it's different in this version of KiCad than the other. Normally, you would just click it a second time to get out of it, in the nightly version, it puts a via, or acts as if it's an actual command. Okay, that explains things, because normally you click it and it would exit out. I have to explicitly click exit. Got it. Okay. Definitely the best part about having done the live stream with the nightlies is I will actually semi-know how this new version works when it releases, unlike normal. Okay. I generally work with a pitch which still have solder mask in between the pins. Yes, it still goes against IPC, because even if there is solder mask in between, you will still have a solid copper piece here, and they'll be a lot more likely to short. Will it do it as much? Of course not, but it still can. So it's a pretty good idea just to try to get it to where they don't connect. And also just like general assembly stuff, it's going to make it a pain in the butt if you ever have to rework, and or it makes it essentially, if it's a QFN, impossible to be able to rework up underneath it. But yes, your point is obviously valid. With solder mask, it's less significant. Any ideas when the new version comes out? I had posted on Discord about it, and I haven't done my Discord plug yet. If you haven't joined yet, make sure to check the description. Join our Discord. Nobody there knew, and judging by still like how many like bugs and stuff I'm finding, I think we've got probably still a minute. I would say probably by the end of the year, but I'm not thinking any time like soon. There's still a lot of issues. Okay, I think that's all the vias here. Oh, one more. And when I redo this, redo all the traces for the final one, also probably move the vias a bit closer. One thing that doing it this way is kind of forcing on us, I might actually change this and move these over and put our via here. So this is something, there's a lot here that is new to me, because normally you have the ground and power pin. I really don't know. I'm going to have to check their evaluation boards to see how they do it. But yeah, I'm thinking putting the via here helps. It obviously adds more inductance to this trace, but our issue is we can't really put our ground. I really don't like this IC footprint, because this forces us to have a pretty big loop area no matter what we do. Actually, let me pull up the data sheet. If there's a chance that they want this to be double-sided, which I don't remember it being that, but that would be a really big pain. And I certainly hope not. Let me go to their website, because I know they have a doc on a couple sample boards that they did. I did the trace across pins with an FPC connector. My fab house didn't care, but it was impossible to hand solder. Yes, exactly. For tutorial like videos, maybe do an analysis of existing circuits like the other day, voltage reference. Yeah, and that's one of the things I want to start doing. Same thing also. A couple people recommended doing like videos on like finding a cool IC and like building out a little evaluation board for it, and like showing off like how it works and whatnot. Where is the board? Similar devices, no. Crap. So they have a evaluation board that uses this IC, and I want to find, yeah, it's right here. So it's this. I want to see where they put their caps. And they don't even show it. Okay, but at least we have the part number now. It looks almost like they're doing the exact same thing I am. Oh, they only have it in the bare Gerbers. Ugh. I definitely like when they do, when they have them on a PDF instead. So I use Fab 3000 for DRC, DRM. It's okay, and that's being pretty generous. I honestly am not a big fan. Cam 350 is by far the better option. Gary, who does our layouts, he has a seat, so I just don't feel like paying for another one on my end. So I just stick with Fab 3000. It's okay as a viewer. The DRC DRM is good. It's just it's insanely slow, like unbelievably slow. So that's the biggest issue that I have with it. So like for a 6 or 8 layer board, it takes forever to do it, where Cam 350 will take like a quarter of the time. And it likes to freeze a lot, which is what is happening right now. Completely freezing. Lovely. Okay, maybe I just use... Maybe I use KiCads. Did they update anything with the Gerber viewer on Nightly? On the new version? I actually haven't messed with it at all. And it is not even opening. Maybe my computer does not want to mess with Gerbers right now. Let me see if there's somewhere that just has a rough overview of what it looks like to see where they put them. Okay. Oh, that's a great view. So it looks like if this is single-sided, it looks like they're doing exactly what I'm doing. But I'd still like to know where they put their vias. Oh, here we go. Perfect. Yes, so they are doing exactly... See, like when their layout guys messing around with this, they had to realize this was a terrible, terrible IC. So this is exactly what I was just saying. Normally you want to have the vias right here to reduce the loop area, but the fact that you don't have a ground pin going back here, I don't think it's doing what they think it's doing, because the only ground is here. So the loop area is still this whole section. The only way this works is for anything out here, but okay, well, at least I know now that it's not a double-sided board. So, and then that obviously makes them have to move all their differential pairs around. So for now, I'm just gonna keep it as is and figure out something else later. The Finding Coil I see sounds really cool. Was wondering what kind of level. Yeah, so what I tried to, the niche or whatever I've tried to do for the videos on here is the majority of YouTube is either super, super basic, dumbed down stuff or really, really advanced. And there's not a lot of focus on like real world stuff. So the videos I do are kind of taking like advanced stuff and trying to get rid of a lot of like the useless theory and just putting it into like actual practice, like what I do when I design a board like commercially. So I don't know how much that answered your question, but that's kind of my goal with this stuff. Okay, so that all the power is now done. And yeah, so what they're doing is basically just, see, it's the double click that gets me. That's going to take a while to get used to. I just need to do a single one. And what they aren't really doing is you want to bring the vias as close as possible to reduce the loop area here. And if it was a bigger footprint capacitor, or you're using like micro vias, you could put them in here. Or if you're doing via pad and via and pad plating, you could do it like this, but that is very expensive and usually not worth it. Okay, so now we need to worry about all this nonsense. I need to see looking way to build KCAD. I'm finding it fine. Yeah, and I guess that could be one of the thoughts I had for like the course type stuff that I would potentially do is like maybe building a board starting from like the schematic up and going through like, since I wouldn't be restricted to trying to keep them all condensed, like going into a lot more detail than I normally do. But I'm not really sure, honestly. I would have to think about it. Okay, so now all of these resistors, so here, I'll show you what I mean. So all of these resistors are just like disabling I squared S, disabling I squared C. All of these are just disabling, changing pin functionality and nonsense like that. We absolutely do not care where these are. These should get the absolute lowest precedent of anything else because all they are is logic high or low. So there's no sense in trying to place these like super close to the IC, which could mess up something else. So, and let me see how they did it here. Yeah, so it looks like, actually those weren't them. Oh, they have them all going, obviously, to headers because you have to be able to toggle them. So for stuff like this, if possible, what I'll usually try to do is like just line them up over here and run traces over to them so they're kind of nice and neat. But again, it doesn't matter if they do some crazy route because they're just logic highs and lows. Everything else needs to be routed before them in order of priority. So I think the only other thing on here that matters is to do the crystal. So we can go ahead and do that. Agreed, YouTube is too simple. Yep, exactly. The live stream form is interesting. Yeah, that's what I agree. The one problem I have with live streams, and it doesn't, granted, this has become a super long drawn out series, is it's like placing all these is it's like it's just super tedious. So I just don't know how many people want to watch me like just mindlessly place all these in a row. And that's what has kind of been the issue with live streams in the past, but either way, we'll make it work. So this is a 3v3. Again, this is not a great configuration for the crystal because there's no super good place to put this decoupling cap. Normally they would put a ground on either side. Let me see what they did. They don't even have the decoupling cap anywhere near it. Where's pin 1? So the dot's here. Where'd my screen go? So pin 1. I don't know. So they take... See, man, this is such a goofy footprint. They take the decoupling cap, they give that precedent over the crystal, which is just kind of a compromise that you're normally not used to doing. Normally a decoupling cap would be far enough away to where you can route the crystal with the most precedent or the highest priority. Yeah, that's wonky. I am thinking, and they say this one should go place near IC, of course. Another thing that makes this a pain is because normally I would say, yeah, I guess let's still do that, is we can place this here, so then this will place over here, and then we'll route this here. Yeah, I think that works, and then that allows us to place this crystal with higher priority. You're also talking about the project. Yeah, that's what I'm trying to do. Did they route crystal pin under R40? Yeah, that's what. Yeah, I don't I don't know. Did they? 1, 2, 3. 1, 2. They did. Okay, that is terrible. So then what is R40 for? I don't know why they have two crystals. Obviously, you can swap them or something. But so that is power, which goes to here. Then the two crystal pins. So one goes here. Oh, I guess I can look at their schematics. Let me see what Y1 and Y2 is. But yeah, that is a goofy setup. Okay, so they have their oscillator, and R40 is their series resistor to keep it from overloading. Now, what is Y2? So yes, they don't populate it. So Y2 is not populated, which is what I figured. But that still is a terrible route. And this is why I've mentioned in a few videos, you absolutely owe it to yourself to look at all of the app notes and everything in the example layouts, because sometimes they'll do stuff that really is helpful, and other times they do stuff like this. So Y1 is the one that's populated, and yet it's that far away. Alrighty then. Here, give me a minute. I'm gonna go to the bathroom. I'll be right back. All right, sorry about that. Glad I did the did all the graphics, or else I would have just had to go to a blank screen. Okay. It's a jumper. Yeah, but the reason they have that is you can change it out with a actual resistor to make it so it doesn't overload the crystal, which that's one of my video ideas coming up that I have in backlog, is to do on different crystal series resistors. Well, I appreciate it. I'm glad you think this is a great channel. Okay, so and as everything else, I'm not gonna do any of this final because we're gonna want to potentially pull back. Actually, we can keep those pores there, but we might want to box this out with some ground. But obviously, they don't really care too much. They don't really care about how this is routed, so I guess I don't really have to care. Too many ads, yeah. What's funny is when you get to where you're able to do ads, even when you become to where you can become a partner, even if you don't do ads, YouTube still throws them on. So I always used to think it's like, oh, if someone has ads on their videos, it's because they wanted to make money. It's like, no, YouTube still throws ads on. So it's either like you don't make any money and they play ads, or you don't. Yeah, it's YouTube's gonna YouTube no matter what. Okay, so that is our crystal. Yes, 0 ohm to jump over tracks. Yes, that's a super old school thing too, because back when even like a double layer PCB was super expensive, they would do everything they possibly could to keep the board single layered. So you would just use little resistors to jump over tracks. I honestly don't do it because vias are essentially free nowadays. So now we need obviously our load caps, which, where are they? Oh, right here. And then something I don't think I ever showed on here. So what I always do is, since no matter how you do the calculation for how much your load cap should be, you're always making an assumption of how much your stray capacitance is. And especially if it ends up being kind of a goofy layout like this, the stray capacitance might be a little bit bigger. So I will always have two different values here, assuming a lower stray capacitance and a higher stray capacitance. And I'll start with assuming it's lower. And then if it doesn't work or I see instability, I can always swap out the parts that I've already ordered. Obviously, you can just order them separately, but I'd like to throw them on the schematic like that just in case. So now this one's easy. We throw it here. I also didn't pick a, oh. Huh. Apparently I did this wrong. That's funny. I was going to say, why are they connected to the exact same net? And something that I wish they would do is make it a little bit quicker to, and I don't even know how I do it on this version, restrict buses to horizontal and vertical, because something I do a lot is like do a 45 degree to show where I'm crossing a signal, and having to go into the preferences every time is kind of a pain. Okay, now we have this set up. Okay, so this one's easy. We can put there. This one we would obviously ideally put over here. So maybe let's go and, oh, how do we do this again? This is the one I forget every time I do a live stream. How do I select the entire trace? One day I'll remember. Until then, I'll be deleting them all individually. So maybe let's do this, and this probably makes the route a little more balanced too, because one thing with a crystal, you kind of want to keep the traces roughly the same length if possible. Obviously with the package I got, that's not overly possible, or can't do it completely, but close enough. That 45 degree trick sounds, yeah, right. That's another thing I saw that's kind of like an old school thing. I never used to do it up until like, I don't know, like 6 months or a year ago, and I saw some like old schematics when they like had to do all this stuff by hand. So they had to do like everything in their power to make it as neat as possible. And I noticed that that was something they would almost always do. So I figured, if you can do it on a piece of paper by hand, might as well do it on here. So we'll add, double clicked. Yeah, that'll be by far the biggest thing I have to get used to. And like I said, we'll worry about doing like the guard ring and everything later on with here, because we'll probably end up moving these traces. Is it shift plus? No, how do you can press something and it'll select the entire net so you can delete it. Before you would just hit delete and it would do it with the old version, but now it's something different. I know the little backslash or whatever is how you show the entire net. I don't know how you delete it. In Nightly, there's a shortcut in the left toolbar to switch. Oh, okay. Yeah, I need to check that. U was to delete it. That's what it is. Yes. So if you do U, that selects the entire trace and then hits delete. I need to write down all these things on the new one. Yes, the thing next to the one, which again I forget. That's how you select the entire net to show it. But if you hit U, that lets you delete the entire trace in one go. Okay, so that I believe is everything of any sort of importance on here. Actually, I guess since that's the only other thing I have a note of, we might as well do this resistor. R bias, I have no idea what that actually does internally. I haven't looked at the block diagram that much. The U key is what I learned in the last. I know. It's the problem is I don't use nightly in any of like work related stuff. I don't use nightly. I don't trust changes happening, so we still use the 5.6. So everything I learn on here is the only time I learn anything about it. So now I've gone 2 weeks using the other version, so I end up forgetting everything. So nothing. So here's now what we have to keep in mind. So there's a pretty good chance that we're going to take all of this here and rotate it 45 degrees to offset all of these. And if that's the case, we can probably tuck down this whole section down here. So any of the resistors that aren't really that important, we probably don't want to put any down here because we want to save that space. So I'm thinking we try to put all those over on this side, even the ones here, and just run them on a different layer. If possible, that is. Let me... I guess we have to change the clearance. Okay, that should let them fill. Yeah, so now that connects. And I'll add thermals at the end. I just find it a lot easier to see when everything is solidly connected. But typically everything will still be a thermal at the end just to make soldering a bit easier. Okay, so now this is going to be a pain lining up all of these resistors. So don't need none of that nonsense. We've got to figure out some way logically to route these resistors to where we'll have minimal overlap with the traces. So if we go clockwise, so maybe this is the top, all the traces go in this direction, and then these go from the bottom. I think that gives us the best ability to line these up, because nothing of importance is going to be routed over here. So we can start from this one being on the top. Ironically, that was the... Oh no, right there. Yes, high contrast is super, super helpful. I do that a lot at the end when I'm messing with the silk screen. But for just normal routing, I just hide what I don't want to look at, and it ends up not being a huge deal. So here, I guess let's make, oh boy, let's make a little bit bigger grid. And I know everyone has like their preferences with how they lay out on a grid. Like I've said a few times, stuff like that is one of my one of the things I'm not super good at is aligning everything. So don't take the way I do it. It just becomes, it's something that ends up taking more time than it's usually worth. Oh, all of these are too. Crap. Oh, some of them are. Now this one. Oh, this is not a decoupling cap. Lovely. It is that resistor. So like I said earlier, that's why it's important to go back and check and make sure that what you're actually doing is what should be there. Because if not, it ends up being kind of a pain. So now we're missing one decoupling cap that needs to be on this pin, which isn't. Pin 43, so this needs a cap, and that's on the 3v3. So let's see, one of these probably won't be. Right there. All right. So these go to there. What grid was I on? There you go, 0.2. Now next is this one. So yeah, this is the type of stuff that always kind of not worries me, but I'm not a huge fan with live streams because it's like there's not a whole lot that I'm kind of showing you when I'm just routing all of these. And I guess there's also only so much I can talk about stuff. So this is where like if I'm doing like the course type stuff, do you guys like the not projects but like going through like a design step by step, or would you rather it be like an actual like I don't know, like lecture type things where I'm going over specific topics? Because I really would like to avoid like just empty time like this if it's something that's going to be live. If it's recorded, obviously that's a completely different story because I can just skip through all this. Should have like music on the stream in the background, or I guess you guys can probably manage that. It is crazy how many logic switches are on here that can be set, but it's nice because this IC gives you the ability to hang on. It gives you the ability to do this over I2C or SPI. So the reason all of these like jumper logic set things are set is because I had to configure them all like statically with hardware. Where if this was done software, you wouldn't have to set all these. But it's kind of excessive. Because yeah, we're going to run out of room here. We're gonna have to like double stack them. So these go around. So they go here, 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 here. I guess what we can maybe do is move as many as we need up like this, because there shouldn't be anything important running there, and just do it with as many as we need. Does KiCad have an align distribute? It does. I've never had a ton of luck with it. Maybe someone else has. The best thing that they can do is like with hierarchical sheets, they will jump them together. Oh, so now it says unconnected. Oh, because that's a non-connect pin. Okay. Like hierarchical sheets will lump them all together, which is why I was able to drag all these over at once. But to actually like align them any further, not really that I'm aware of. And it's like, yes, it's tedious and takes a little bit, but it's usually not terrible. And I mean, this is about as extreme of a case or an example as you'll get. Well, I'm glad you like them. Okay. What is this? Oh, that's one of the resistors. God, that is so many resistors for that. Okay, so let's move these over. So what else GN and some other people have mentioned like asking about KiCad. So what ECAD softwares do you guys use? I learned the most from seeing someone do it, but doing it for real, not edit it. Yeah, that's what I always try to do. Even when I would do recordings, I hate how people would just jump and like show a layout like this in one go. Like, oh yeah, I know exactly where everything's gonna go and route everything, and it just makes you feel either like one, they're clearly lying, or two, they are like the single greatest layout person ever. Because yeah, I mean, it's layout is it's like an art. You have to do it once, completely mess things up and find a better way to do it, and then you just keep getting better and better as it goes on. But that's why definitely one of the things I like about the streams. Oh no, did I miss a resistor? What is this? Oh, this is the cap right here. So that just ties in with the other. And see what you're saying about dead air. You like this. You have better understanding. They can ask direct questions. Okay, well, cool. That's good to know. So then this will go up here. Man, this is gonna mess up my entire. All these are perfectly in line, and now this one's gonna break it. Dang it. Maybe we just do like that. Because like this is the stuff with the grid. It's like to make this look really pretty, you have to go to a smaller grid and then change it back, but whatever. KiCad, easy EDA, gotcha. Speaking of silkscreen, yes, no, I am MSCNC totally. I like that the DRC does it. I just don't want to have to worry about that right now because that's one of the last things I'll mess with. But yes, normally we would have to export our Gerber, then do Fab 3000 or Cam 350, which would pick up on it, and then go back and change it. Having the actual ECAD do that on the DRC is amazing. So I'm definitely going to be using that. Minimal spacing on silkscreen. Gotcha. Yeah, like I said, I haven't done a full DRC with it yet. Okay, so now for all of these routes, I'm just going to throw them on the bottom copper. I don't see any reason to do anything else. The one thing I'm kind of worried about, and I'm hesitant routing these right now, is depending on what we decide with the decoupling caps, if we do have vias somewhere in here, that's going to mess up how all these are done. Because if they're going over where one of those vias would be, obviously we have to rechange how those are. Oh, crap. What is this one? Oh, I did miss a single resistor. So where does that go? Okay, I guess I do have to at least do them roughly. First stream for me, briefly explain the project and the main chips you're doing. Man, this is the 8th video on this. But it's just it's a USB hub, USB-C upstream, gets filtered, goes into a mux, which handles the orientation, goes into a hub, which has 4 downstream ports, which are handled by a V-bus monitor. We have 2 bucks, a LDO, a input filter, and each of these are able to source like 3-ish amps on each. As for the ICs, I'm not going to go through each of those. It's in all the other videos, but that's the gist of it. So yeah, I guess we do kind of have to at least roughly route all of these. But maybe we do kind of, oh gosh. Maybe we do kind of try to stay out at least somewhat wide here. And just to recap, all of these resistors are just logic latching to set parameters, so we don't care how crappy or how long these routes are, because it's just a static on-off. There's no actual signaling going on. Stop doubting yourself, having dead air, food your punch. All right, I'll take it from you. But that I do obviously really appreciate the input, because for me, I mean, obviously I don't really know how it comes off, and I'm glad that you guys are liking the whole format and everything, because it's definitely a lot easier for me than editing all these videos. There's no way I would have finished this USB hub if I had been doing them all on like recorded clips. It takes so much longer, because what you have to keep in mind is this is a 2-hour stream. So if I was doing this as a recording, I would still spend the 2+ hours, but then I have, oh man, but then I have however many other hours editing it, so it just becomes a complete nightmare. I guess let's see if we can shoot this in, because I'm not going to be changing. Man, I don't really want to route these now, because we're going to have to change where all these decoupling caps are, and that's just going to be really, really redundant doing all of these. So let me just figure out exactly where this one goes. So it should go below this one. So we'll move. So let's delete all of these. Oh, but it doesn't delete the U thing, doesn't delete the traces on other layers, so it's not as powerful as the old KiCad doing the just select delete. There's 3 vias. Okay, I know I didn't click 3 times. There's 4 vias. Are those actually separate? They are. So that's gotta be a bug. There's no way I am clicking 4 times on that trace. They just really want to tell the fab that there's gotta be a via there. So that's why it's not deleting all in one go, is because there's so many vias in line. It probably gets confused. Yeah, 3 vias here. 4. Well, I'm glad I can help you with that. Oh, I have to hit you twice. Oh. Let me... No, I'm not about to do all that. I'll test it on the next time there's... Oh, I can do it on these, actually. So you once... Got it. Okay, that's really cool. Got it. I mean, it's cool, but it is extra clicks from how the old version was. But like I've said before, if it makes it more in line with the schematic editor, which it is, I'm not really going to complain, because that's one of the big things that's frustrating with the standard KiCad right now is there's such a discrepancy between them. Yeah, I wish they would automatically lay it out. I definitely like the curved rat's nest. That looks so much better than if it was just that. Missed 1 hour. Yeah, well, you can always watch it on a recap. These go public after the live stream. They don't get deleted. So that's the old, one of the extra load resistors for the crystal. So what I do with those, and I know with the new version, I can set them to be excluded from board, which I should have done. But for now, I'll just delete them and just know that every time I update the board, it will automatically put them back on here. That has to be redeleted. Yeah, exactly. What did you do for 2 hours? I placed resistors, drew a pour. Okay. Um, so next. So this is all for... So whoever had asked earlier, does it do any grouping? So one of the hierarchical sheets is the buck for the 1.15 volts. So all of the parts for that are lumped together. So it might not do any others, but it at least does these here, which makes it a good bit easier to at least keep things all together. And then same thing with the 3v3 LDO. What are these for? These are all for the mucks. I don't know how those got missed. And this is also for the mucks. This is for the 5-volt buck. Man, a couple things got thrown around here. That's mucks, mucks, mucks. So did I not fully... Oh, I didn't fully route this. I thought that was already done. I see you made up your mind. Still no angled positioning. No, I think I am gonna do these angled. That's what I was talking about earlier. So what I wanted to do is place all of this now, because if you see when I go and adjust it on a 45, now all of these are already adjusted on that 45 instead of having to manually do them all. So no, I do think that the way to do this on the final spin of this will be to have it angled, but I'm going to wait until we get further along to do that. I did draw a few tracks. Okay. So, I know I keep pushing down the power side. It's just because I want to make sure everything else is placed before we figure out exactly where the power side goes. So I guess the easiest is, so the 12 volt side. So the 12 volts definitely will stay up here because nothing down here uses 12 volts. So we could have a 12 volt pour, and this is probably the conclusion that we had talked about in the last stream. I really need to make notes of what kind of the plan for the next video is. So 12 volts will be up here because it doesn't run down here. Now 1.15 is only down here. There's nothing up here. So, right? Yeah. So the 1.15 buck probably makes sense to be either here or there. And it takes in, it takes in 12 volts. Yeah, see, that's the problem doing the 45. That's why I like doing it here first, because it takes so much longer to rotate. Okay, so that's a problem if we want to keep the 12 volts up here, if we want to have the 1.15 buck, but I think that's a trade-off we would take because, not that it matters, but with the 1.15 being such a lower voltage, it's going to be more susceptible to noise. So I'm thinking we do want the 1.15 closer to the hub. So then likely we would do 12 volt up here and then just split our power plane or one of the planes and have 12 volts run down here. The good thing is on the 12 volt side to the buck, let me see. It only draws 2.5 amps downstream. So on the 12 volt side, it's only drawing 300 milliamps. So we don't even need a pour for the 12 volt. We can just use a big trace because that's nothing. So we can have the 1.15 here giving power to this. Then our 12 volt stays here, and then our 5 volts goes to these, which needs to be beefy. What if we... I don't know if we have the space, but it would be nice to have MSNBC. Yeah, that it's been hard to say that username without saying MSNBC. It would be nice to have this 5 volt buck right here, but with how big that inductor is, I do not think that's happening. So I think it's fine to have it over here maybe, and then just have the pour on the 5 volt side. Does anyone have any thoughts with the power pours? Anything against what I said or for it? Really, the only major change is just we have the 1.15 here, have a trace down there, and then move the 5 volt as close here. But I do think, just to get rid of all this crap, we should do the mux better. And then that's where we can hopefully be at the end of this stream. And then the next stream will be to do the power side and then potentially start on some final routing. I kind of doubt it. I think we're still going to need some fine-tuning of placements. Oh, well, here's where my rough idea was before. So having the 12 volt there. But that doesn't hold anymore because I want to have the other buck down here. So let's get rid of that. But I'm definitely thinking prepare for V1, say yeah. Yeah, definitely thick on it. But again, the key is with just the 300 milliamps, it won't be that much current. But yeah, I'm thinking we make our power port primarily the 5 volts because it needs to get down here, and we have a pretty good path. And then just carve out for the 12 volt and everything else. I think that's gonna work out nice. Okay, so let's figure out this mux and why we didn't actually route anything else before with it. God, this looks like a complete cluster. Not sure if I would keep the ground separate, but that was the first idea. I don't know what you mean by keeping the ground separate. All of our grounds are tied together. We don't have any split grounds. The only different one is where it comes in before the common mode choke, which is obviously required. But everything else, all the grounds are tied together. So it'll just be referencing the ground pour on layer 2 or layer 5. Yeah, this is going to be a pain. Okay, so these two we need to flip-flop. And I'm going to be doing this a lot, and I don't want to have to keep switching screens to show. So all I'm going to do is like when I need to swap those, since the TVS diodes, they don't matter where anything is. So I'm just going to go and like swap these two here, and then I'll pull it back on the PCB, and then it's going to flip-flop these. So I'm just going to be doing that quite a bit. So just know that's, and there are the load caps. So I'll just keep them off to the side so it doesn't keep pulling them. Since all is tied to the same potential, then only the differential pair for the VCC and 12 volt. Yeah, but since all is tied to the same potential, yes, exactly. They're all tied to the same. Okay, so... Oh, don't do that. That's annoying. I remembered it doing that before. So it doesn't like that these are not ending in a capital N, and instead they are ending in a lowercase n. But that means these are gonna be all screwy too. Crap. Maybe what's easier is we change the naming with labels. Yeah, well, the good thing with this new nightly is, or the final version, it's going to have a backwards annotation to where they can sync it from changing the net on the PCB side, which is one big thing that it's been missing. Obviously, that should be there. Okay, this is gonna be really annoying. And while I guess not a not a bug, ending with a lowercase n should still count. Oh, this is gonna get really messy. So let me just see how this one works. So these should work. No. You're not starting a differential. Oh, because this isn't tied to the right one. Right. Oh, yeah, I can just do it here. Okay, so yes, those will route. You moved a block which you didn't need to. Northeast. What did I move? On the schematic? I do not know where you're talking about. So let me reverse this. Because since we only need to do it on the right side, then we can probably just do this. Because I'm trying to avoid changing these names because I don't like having the outside be different than what it is on the IC. Even though it's just a polarization thing, I'd still rather not have to. So yeah, that's something if anyone wants to relay to any of the KiCad devs, let it work with a lowercase n and p for differential pairs. There's no reason why it should be limited on the capital. Oh, so it was on the schematic, so then I should have fixed it, right? Because I just deleted it anyway. Whoa. That's weird. I don't know what that was. Are you talking on the PCB with the differential pair? RX1N, RX1P, TX1N, TX1P. RX2N, RX2N. It's just to keep the spacing correct, or at least as close as they can, because if it were to connect at the center, the spacing would be off. At least that's what I think you're asking. RX2N, RX2P, and obviously if anyone sees me mess any of these labels off, please let me know. TX2N, TX2P. It might be quicker to edit in the file. Yeah, probably, but that wasn't too bad. Okay, so now we should be able to use the... Yep, perfect. Okay, we are going to have to move these back a bit. And the whole goal with TVS diodes is to keep the... Oh, crap, those are on the other side. We want to keep them as close as possible to the connector, so the ESD event doesn't travel on the board as long as it can. So that's why you do want to keep these pretty close. So now we got to swap these. God, does not like this. I have no idea why it's so unhappy with this. So what I'll do is just, oh boy, is just keep those where they were, and then I'll just route the differential pairs to it. Maybe rotate the package 180. No, because they just pass through. I'll just swap them out as I go. Either or works. What you're saying works fine. I just think it's probably a little quicker changing them each time. It will be better to start from routing from the USB connector. You mean so it doesn't get all janky up here? Maybe. I'll try it on the next one. I wouldn't be surprised. Oh, come on. Yeah, this differential pair router is not good anymore. I mean, it had its issues, but holy cow. Hello? Um, that's weird. Yeah, well, it still didn't like doing that, so... Oh, wait. Oh, this is supposed to go through... I don't really know why that was able to connect. Okay, something got all messed up on the net names. Um, so... Okay, this is... Okay, we might have to end this here. This is something I was wondering. I guess this isn't a bug with KiCad. This is just how it handles hierarchical sheets. So TX2 plus goes to TX2 plus in, but in here, there's TX2 plus. So basically, there's two nets that are different, named the exact same thing on here, which is obviously messing it up. So what I think we'll have to do is change all of these net names and then probably anywhere else where I did that. So like down here, and change the name to be like internal or just like an underscore to it. Because right now it's saying that this is connected to this because they're the same name, even though it has to go through this cap. So I guess I can at least try it on a couple of these, because I'm thinking just do something like that. Yeah, it's definitely a first for me. I kind of expected it to happen at some point, but thought it would error at least. Maybe it is something on the DRC that it does get mad about. So let's see what that does. Yeah, so now these are not, at least they shouldn't be. Yeah, they're not connected here anymore. Okay, so that does actually fix it. Cool. So then now I guess we have to move these back again to give us space for those. Yeah, but that's remember, input goes to out. Yeah, so all this is doing is just passing these signals through, but it's having the TVS diodes on each of these. So it's just internally naming these nets different. If the TVS diodes were just attached directly without these, oh, yes, I got it. I gotcha. Yeah, so I mean, this is totally my fault on getting these all confused, and I'm gonna think about a better way to do this, but I wonder what is the solution here when you have differential pairs that are going to be named the same thing at different spots. I guess I'll name this one too. Because I think KiCad, I mean, it's handling it the way I told it. It's just not in a good way. Okay, so now that should fix it. Okay, so RX, P, and N. No, it's still not doing it right. Okay, no, it is. Because this cap should be down here. Yes. Now we're sorted, I believe. So this goes through here, and then the other cap. So was it actually fine at the start? I don't know. That kind of confused me. But I do believe we are good now. And I do think naming it with that internal name, doing the underscore probably is the right way to handle it. But I'm definitely going to check into that later. Yeah, nice work, router. That's exactly what I want it to look like. It's like it's not even trying. And I know why it's doing that. It's because the caps aren't perfectly centered with this. But it should be able to handle it in a little bit better way than this. So I guess that's where we just do it by hand. Alright, so I think I'll leave it here for today. So next stream we'll just wrap this up, which hopefully now that I figured out that mess up, yeah, exactly. Agreed. It's with the design rules, and that diff router is not very good right now. But yeah, so we'll wrap up this, which shouldn't be too bad. Then we will do the part that I've been delaying and figure out the power side. And I'm thinking in that next video or the next stream, can probably get the power side done. So then it'll just be adjusting any traces, and then we'll be ready to start working on the actual final routes of everything. But yeah, I appreciate it, guys, for watching. If you haven't, description has the GitHub. It has the link to the Discord. Make sure you check those out. I'll have a video up next weekend, and then the next stream will be in 2 weeks. I'm kind of doing them one by one. So I will catch you guys on the next one. Have a good one.